So this week, we're going to start something new. We'll start matrices, and we'll be in matrices for most of the rest of the semester, I guess, mostly through April. But let's take a look. Oh, we got the blinky blinky. Once I click on the grade screen, there we go. You should be done with the Module 6 exam. That was last week. Was the exam. It's only worth 65 points. This wasn't as big of a test as the others. But if you look ahead, there's a lot of this just because it's all individual assignments. But like this week, we're doing 3 assignments. These are very, very short. Just 3 this week, 3 when we get back from spring break, 3 this. So we're doing 2 to 3 every week. Oh, then there's a 4 a week. And then, so this will take us all the way into May, so all the way through April. So this will pretty much wrap up your senior year, because I think you're only in school one more week after May 4th. So this will pretty much take you through the rest of the semester going through matrices. But we're going to start with, and I'll show you how to do this. So I'll probably have you guys check. We're going to do this on Khan Academy. So let me go back to the activities here. And we're going to close the conics. We're done with that. Matrix Operations has its own folder here, and there's a bunch of folders inside of it. So I need to go back and let's make note exactly which ones we're doing. So this week we have matrix dimensions, matrix elements, and representing linear systems. So you're going to need to go to the grade screen a lot to figure out what you have to do each week. Or you go to Google Classroom, because I got it in there as well. But let's go starting the matrix unit. Okay, this is where you need to go to make sure you are logged into Khan Academy and you're in my class. So you should have, if you're not in Khan Academy, you should have got an email on Thursday of last week inviting you to join Khan Academy and put you automatically in my class. But go ahead and click on the first hour link, starting the matrix unit, to make sure that you are already in my Khan Academy class. If you don't get signed in and you forget to log your score, you'll have to redo the assignments. You don't want to have to redo the assignments. If you're logged in, it will remember. So if you forget, it'll already know you've done it. So that's right there. First hour, make sure you have joined my Khan Academy class. All right. Let's go to the first folder, Intro to Matrices. When you open that up, you'll see there's a video, there's a lesson, and then there's 2 assignments. So we're going to do the first 2 folders. We're going to do the Intro to Matrices folder and the Representing Linear Systems folder. So we've got a video, we've got a lesson, we got 2 assignments, and then we have another lesson and another assignment. So this is what we're doing. And this will not take a lot of time. These assignments are just a few minutes each. That's why we have 3 of them. So this isn't bad. So we're going to start out with the Intro to Matrices video. So when you click on that, there's going to be a link. There's a link. And all of these will take you to link to Khan Academy. When I click that, it'll open up the Khan Academy window. And this is where you want to make sure, when you're doing the assignments at least, that you're logged in. But let's watch this video first. When we get to the assignments, we'll look at those together as well. Pretty short, 4.5 minutes.
What I want to do in this video is explore the notion of a matrix outside of the context of a surprisingly good movie that involves Keanu Reeves, and it's actually the first of 3. I guess we could call the 3 movies combined the Matrices. And there is a relationship between the movie, which is about a virtual reality constructed by super smart computers, and the relation and the notion of what a matrix is when you study it in mathematics or when you study it in computer science. And the connection really is that matrices are used a lot when you are simulating things or when you're constructing things in computer science, especially in, frankly, computer graphics. So the super intelligent robots that made the matrix in the movie Matrix were probably using matrices in order to do it, if they actually did exist. Now, what is a matrix then? Well, that's a fairly simple answer. It's just a rectangular array of numbers. So for example, this right over here, if I have 1, 0, -7, pi, 5, and I don't know, 11. This is a matrix. This is a matrix where 1, 0, -7, pi, each of those are an entry in the matrix. This matrix right over here has two rows, and it has three columns. And because it has two rows and three columns, people will often say that this is a 2 by 3 matrix. Whenever they say it's a something by something matrix, they're telling you that it has two rows. So you see the two rows right over there, and they're telling you that it has three columns. You see the three columns right over there. I could give you other examples of a matrix. So I could have a 1 by 1 matrix. So I could have the matrix 1. This right over here is a 1 by 1 matrix. It has one row, one column. I could have a matrix like this, 3, 7, and 17. What is this? Well, this has one row. This is the one row we see here, and it has three columns. This is a 1 by 3 matrix. I could have a matrix, and I think you see where all of this is going. Figuring out the dimensions of a matrix are not too difficult. I could have a matrix that looks like this, where it's 3, 5, 0, 0, -1, -7. This 7, -7. This right over here has three rows. So it's three rows, and it has two columns. So we would call this a 3 by 2. Oh, let me do that in that same color. We would call it a 3 by 2 matrix. 3 rows and 2 columns. So fair enough. You know that a matrix is just a rectangular array of numbers. You can say what its dimensions are. You know that each of these numbers that take one of these positions, we just call those entries. But what are matrices good for? I still might not be clear what the connection is between this and this right over here. And at the most fundamental level, these are just ways, this is just a compact representation of a bunch of numbers. It's a way of representing information. They become very valuable in computer graphics because these numbers could represent the color intensity at a certain point. They could represent whether an object is there at a certain point. And as we develop an algebra around matrices, and when we talk about developing an algebra around matrices, we're going to talk about operations that we're going to perform on matrices that we would normally perform with numbers. So we're going to learn how, or we're going to essentially define how to multiply matrices, how to add matrices, how to we'll learn about taking an inverse of a matrix. And by coming up with an algebra of how we manipulate these things, it'll become very useful in the future when you're trying to write a computer graphics program, or you're trying to do an economic simulation or a probability simulation, to say, oh, I have this matrix that represents where different particles are in space, or I have this matrix that represents the state of some type of a game. And I know the algebra of matrices, and I know ways of doing it very efficiently so that I can multiply a bunch of them, or I could run a simulation and I can actually come up with useful results. So that's all matrices are, but as you'll see through this, we can define operations on them. And then later on, when you take a linear algebra course in college, you'll learn a lot more of the depth of how they can be applied and what you can use them to represent.
Okay, so basically it just says that a matrix, that was just our intro, that you look at the rows first and then the columns. So if we go back to Buzz, that was the intro to matrices video. Now we have the lesson, which basically gives us a chance to practice. So I will have the chat on so you guys can participate. But let's look at the lesson, which basically goes over what he just gave us on the video, but just puts it in lesson form that we can read through. So when you go to Khan Academy, make sure you're logged in. See, he's got my name up there, Mr. Brock, in the corner. If you're not logged in, it won't keep track of what you've done in here, which you don't have to have it keep track, because I'm going to have you turn it in with screenshots. But if you don't screenshot it, you'll have to go back and redo it if you don't log in. So being logged in is the best way to do this. So when it always opens, it always has this little menu on the left open. I just close that to give us more room on the screen. But intro to matrices. So a matrix is a rectangular arrangement of numbers in the rows and columns. That's all a matrix is. It takes numbers and puts them into rows and columns. For example, matrix A right here has 2 rows and 3 columns. Simple enough. So we call this a 2 by 3 matrix. The dimensions of a matrix tells its size, the number of rows, and the number of columns in that order. So matrix A is a 2 by 3. 2 by 3, rows first. In contrast, matrix B, shown below, is a 3 by 2 because it has 3 rows and just 2 up and down columns. So when working with matrices, that's the key to remember. It's always rows by columns. Rows by columns. So here's our class participation portion of this lesson. What are the dimensions of matrix D? Put that in the chat. What are the dimensions? All right, you guys are on this. All right, how big is this? It is 4 rows, 3 columns. Great. So when we hit check, it'll give us a little green check mark. So you can go through these lessons as well yourself and just double check if you're like, oh, I'm not sure that I understand this. This is, I just clicked the same link that you have. Same link here. What about this one? What's the dimensions of matrix E? Right here is E. Yes, you're right. The last one was a 4 by 3. All right. Yep, we're walking through this very basics. 2 by 4. Great job. Hit the check. Absolutely. How about matrix F? I've got 2 different answers. Oh, Madison changed her answer. Now I got the same answer. Yeah, it's got 3 rows and 1 column. 1, 2, 3. It's a 3 by 1. Absolutely. Now let's talk about the elements. Each of these entries, each of these numbers is an element. So a matrix element is simply a matrix entry. And we can name elements like G21, 2, 1 means we're talking about the element that's in the second row and the first column. So G2, 1 is 18. That makes sense? If we say G2, 1, first row, second row, so I want this row, and 1 is the first column, so 18 is G2, 1. So it's generally I, J, with I being the row and J being the column. So for matrix A, what is A1, 3? Which one of those entries, which element is A1, 3? You got a couple folks got that figured out pretty quickly? Yeah, 1, 3. So 1 means the first row, so it's going to be on the top row. 3 is the column, first column, second column, third column. Yeah, must be the 8. The 8 is 1, 3. How about B2, 1? Getting different answers. Jonathan and Amber got different answers here. Oh, Jonathan looked too quickly. He went 2, 2. Yep. That's it. 2, 1. Second row. First one is the 4.6. Good correction there, Jonathan. There it is. All right. Here's a multiple choice, A, B, C, or D. Matrix C is a 2 by 3 matrix. That's important. Where 1, 2 is 6. It's a 2 by 3, and 1, 2 is 6. 2 by 3, 1, 2 is 6. Seeing C's and B's. Yeah, put it up again. Since I got B's and C's, I won't show D because D's not. It's a 2 by 3, and 1, 2 is 6. So first you got to look at and see which one's a 2 by 3. Well, the only 2 by 3s that I see This is a 3 by 2. This is a 3 by 2. This is a 2 by 3. This is a 2 by 3. It has to be C or D because the other ones are the wrong size. 2 by 3. And 1 comma 2 is 6. It's got to be C, right? C, yeah. That's why we practice these, because it's easy to make that little mistake when we're still figuring out matrices. Rows by columns. Yeah, it is C. 2 by 3. 2 by 3. All right. Good job. Good job. Okay, so that is the Intro to Matrices lessons. One was a video, one was a lesson. Now we have 2 assignments, and these will be different for everybody. The problems you see that I have on the screen will probably be different than what you have on the screen, but it works exactly the same way. So this is how we do this. When I go to this screen, make sure you're logged in. After clicking on the link below and doing the problems, that's the big important thing. Take a screenshot of your score, and I'll show you how we're going to do this. And then if you scroll down, look at this when I scroll down. Oh, here it is. Here's where we turn on our score. Here's where I turn on our score. So I'm going to click on the assignment. Here's the assignment. It's going to open up a Khan Academy window again. It's going to open up that little side menu that I'm going to close again. I've got my name up here, so I feel good about this. Now, look, I have done this assignment before. So it's already got my score of 100%. If I forgot to screenshot it when I did it, I can take a screenshot of this and turn it in. But I'm going to do it again because I'm showing you how to do this in our class here. So here's the assignment. Matrix dimensions, ready to practice, 4 questions. Each of these just have 4 questions. Down in the corner, you see it says, let's go. So when we click on that, it'll give us our first question. And our first question is, what are the dimensions of this matrix? So what is this? We got this matrix. What are the dimensions? It'll keep track at the bottom of the screen, by the way, how many we've got done and how many are correct. So this is rows by columns, 3 by 4. 3 by 4. Jonathan's got it. Now here's what you do. When you hit check, hopefully you see this little green check mark. Nice work. If you missed it and you're like, wait a minute, I thought I was right, you can click on show how we answer this question, and it'll give you the reason that's the answer. The first dimension is the number of rows. There are 3 rows. The second dimension is the number of columns. There are 4 columns. In conclusion, the dimensions of this matrix are 3 by 4. So it'll tell you, it'll have a button, if we got it wrong, it might say hints if we want a hint. But once we're done with that, look, at the bottom of the screen, we got this green check mark. We got the first one right. Next question. Here's our next question. What are the dimensions of this matrix? So what do you got there? What is that? Put that in the chat. Jonathan's quickly on that. This one's a lot easier, right? Because it's the same number of rows and number of columns. So this one's pretty simple. It's a 3 by 3. Feel pretty good about that. Hit check. All right, I've got 2 correct. I can see at the bottom of the screen. They're both right. Okay, next question. Oh, what's the dimensions of this matrix? Put that in the chat. Jonathan's not going to have any trouble with this assignment. He's got it. He's got it. Shay's on top of it. All right. Remember, it's rows first, and there are 4 rows, but there's only 1 column. Check. I'm feeling good. I've got 3 in a row down here at the bottom. Next question. What are the dimensions of this matrix? It's a 3, 3, -6, -6 matrix. It's simply a 2 by 2. That one's pretty easy. It's the same rows and columns. All right. Good work. 4 in a row. This is the important screen right. Here's the important step. Don't miss this. Here's my score. Here's my score right here. So I'm going to stop right here, and I'm going to take a screenshot of this page right here. There we go. There's my screenshot. So I just opened my screenshot. Showing you my screenshot. Now I can go back. I can close this, scroll to the bottom, and paste it. You may have to attach it. It may save it as a file and you attach it. I'm not sure how it works, an image file or a Google file, however it saves it in your Chromebook. But this is what I'm turning in. See, it's my matrix dimensions, 4 out of 4, submit my work, and it's turned in. So then I'll go in and I'll look at that and give you full credit for that assignment. Now, what happens if I close another window and I forgot to do this? Oh man, I forgot that. Let me go back to that assignment. I'm gonna go back to the assignment at Khan Academy. And I forgot to screenshot it. Oh my goodness. Well, since I'm logged in, I've got my score right down here on the left on that menu. So I can say, okay, well, I'm going to screenshot that. You can screenshot the whole page if you need to, but it's like, I'm going to screenshot that. And I can turn that screenshot in. Look, I've got a screenshot that says I made 100% on matrix dimensions. I don't have to do it again. If I'm not logged in, it won't have a score here, and I got to do it again. Oh, man, I got to do it again. I wasn't logged in. It didn't save my score for me. Now, here's my tip for this. You don't have to take a screenshot until you get a score you want. What if you did have it backwards in your head? Say, oh, I got 2 out of 4. Oh, I'll just do it again. Because it doesn't take much time, right? It's just 4 questions. You type it in and go, boom. I mean, that took us very little time, and I was even stopping and talking about it the whole time. If I'd just done it, it would have been less than a minute, right? Just putting the dimensions in. So a lot of these are really short, really quick. Don't turn in 2 out of 4. I mean, I've taught this for several years this way, and I've only had one person turn in a 1 out of 4, and that was this year. I couldn't believe he did it. Like, why'd you turn in a 1 out of 4? Okay, I'll give you 25% on it. I don't know why you would, but I did have. I mean, he was a sophomore. You know, he was. But yeah, don't turn in. No one's ever turned in 0 out of 4. That'd really be. It's like, well, I got a 0. Don't do that. Go do it again. You can click and redo it as many times as you want to. It doesn't matter if you've already done it. It'll let you keep redoing it. In fact, when you finish it, if you got 2 out of 4, there's a button down in the corner that says retry. You don't even have to close it and reopen it. Just hit retry and it'll start it over for you. Turn in the score you want. A lot of people, and I see this every year, and that's why I like the matrix unit. I see scores go up for the semester grade. I see people's grade go up because they're able to do these until they get the score they want, and they turn in 100%, 100%, 100%, 100%, and their grade starts going up in the class. And by the end of the matrices, they got a lot better grade than they started with. So matrices are pretty quick and not very difficult to understand. And you have the lessons you can go back and look at, and some of them have videos you can go back and look like. If you got confused, you can go back and look at the lesson again. Oh, that's how we do that. And even these that show you how to do it. If you get it wrong, you can click show me how to do this. Okay, now I can do it right. So this is a great way to raise your grade for throughout the rest of March and April. Is make sure you're turning in grades you want, because you don't have to turn it in until you decide to take a screenshot. That's what I like about the matrix unit. All right, let's get back and look at our other assignments here. So I have turned this one in. I have taken my screenshot. I have submitted that. So I can go back here now. So matrix dimensions is done. Now I have the matrix elements assignment, and then we'll have one more down here. See why we're doing like 3 in 1 week. This is really quick. I mean, we've only been here in class 30 minutes, and we're flying right through this. Okay, again, when you see this, this is where we're putting a screenshot. On the same page that the link is on. It's just that I wish I could get rid of this space. It won't let me. I've tried to get rid of I can't figure out a way to get rid of all this space. I wish this submission was up here in this area. But let's click on this. It'll take us back to Khan Academy. If we was logged in before, we should still be logged in. Doesn't hurt to double check, but it's been very slow loading. There's my name up there. I'm good. I'm logged in. Matrix elements. And see, I've done this one before too. But all right, ready to practice. Okay, show what you can do. Let's go. All right, put this in the chat. A3, 4. Which number is that? Which element is 3,4. Well, y'all are saying nothing. Oh, 0. I guess that's not nothing. 0 is a number. Third row, fourth column. Yeah. Third row, fourth column. Yeah, it's a 0. Good work. There's number 1. Next question. 4,5. 4,5. Yeah. And I like how they give you right here. If I'm lost, look here. Here's the 2 things we looked at. Here's the video. Here's the lesson. I could right click and open those in a new window and then come back to this if I couldn't remember. It tells us the lessons. But yeah, 4th row, 5th column. It's the very last number in this one. Check. Great work. Next question. 2,1. 2,1. Yeah, it's the second row, first column, first number in the second row. Next question. 3,3. Which one is 3,3? Yeah, 3,3 is the last one, right? 3,3, it's the very last 8 right there. Great. Show summary. Screenshot. No. There it is. Got my screenshot. Scroll down. Paste. Yay. Submit. Don't forget to submit. You got to hit the submit button down there. All right. It's been turned in. Okay. When I go back, I am now done with the introduction to matrix folder. I'm going to go ahead and close that. All that's left is the second folder representing linear systems of equations with augmented matrices. Click on that. Let's look at this lesson. All right, now pay attention here. This isn't difficult, but you got to pay attention to the details. I don't want you to get lost because you weren't paying good attention to start with. But the nice thing is you've got this lesson. You can go through this exactly too. The lessons always start out reminding you what a matrix is. Rectangular arrangement of numbers, rows and columns. This is a 2x3. Okay, we're going to talk about representing a linear system. That means the systems of equations. Right? If we had the system of equations right here to solve, we've got 2x plus 5y equals 10 and 3x plus 4y equals 24. We can make that into a matrix. We just take an x column and a y column and a constant column. So we would take the 2 and the 5 and the 10 and put them as our first row of our augmented matrix. Take the 3, the 4, and the 24. So basically, we're just losing the variables and just keeping the coefficients. So each row is equal to one of the equations. See, the only thing that's on row 1 is numbers from equation 1. And the only thing on row 2 is equation 2. And the columns represent either a variable or the constant. So the only thing in this column is going to be the x's. The only thing in this column is going to be the y's. The only thing here is the constants that's equal to. So this is converting this into this. And in future weeks, we'll solve systems of equations using matrices. So we'll show you, but we need to know how to make it a matrix. So if we go down here, which matrix represents this system of equations? Is it A or is it B? A or B, which one represents this systems of equations? Jonathan corrected himself. First he thought it was A, then he looked closer and went, oh, wait a minute. They are very similar. There's only one difference in those two matrices. Is the second one has reversed the 2 and the 5 on the second row. This is 2, 5, 2 on the second row. This is 5, 2, 2. So if we look at the systems of equations, the second row should be a 5, 2, 2 because the 2 and 5 is the x column. This has 2 and 2 is the X column. That would not be right. 2 and 5 is the X column. All right. This one they want us to write. We have to write this one as our own augmenting matrix. So the first row should be the first equation. And we should put the X's in one column, the Y's in another column, and then the constants. So if we just take the coefficients, 7, 4, and 3. Now in this one, since this is the X, we got to make sure we get the X from the second equation. So that should be the 6, because only X's are in this column. Only Y's are in this one. So that's going to be the 3. And then the 3 and the 5 go there. All right, now we're going to get a little more complicated. We're going to have a system of equations with 3 equations, which generally means with 3 equations, you have 3 variables. So we have 3x minus 2y equals 4. We have x plus 5z equals negative 3. We have negative 4x minus y plus 3z equals 0. So the tricky thing is like the first row, there's no z. The other 2 equations have z's, but there's not one in the first equation. But we have to account for that because the only thing that can be in the z column is z's. So if we rewrite these to have all 3 variables, 3x plus a negative 2y plus 0z equals 4. The second one is missing the y. So it's 1x plus 0y plus 5z. And the last one has all 3. Negative 4. And then they changed it to a plus a negative 1 just to realize negative y means negative 1 is our coefficient plus 3z. So when we turn this into a matrix, it's 3, negative 2, 0, 4 because this is the z column. And that first equation didn't have a z. But in our matrix, we can only put z's in that third column. We can only put y's in the second column. So we got to put a 0 because this was x plus 5z equals negative 3. So that's correct for the second row because that's the equation. But there shouldn't be a number in the y column. It's a 0. It's a 0. Okay, so let's practice one of those. Again, which one, A or B, represents this matrix? A little more complicated. Got to pay attention to the little details. There's only one difference. This one has a 1, 0. This one has a 0, 1. All the other numbers are the same in both matrices. So is it A or is it B for this matrix? There you go. Jonathan believes it's B. Let's see what other folks think. Danielle says it's B. Come on, folks. This is the class participation portion of our lesson. Just to make sure we're getting this. Shay believes it. Well, B seems to be the repeating number here. Everyone's thinking it's B. Well, would you be surprised if I did that and it's wrong? What's missing? What's in? Let's look at the first row. The first row has everything. 3, negative 2, 1, 5, 10. So 3 is the W column. 3 is the W column. We have a W in the second equation. It's a 1, so it should be in the W column. Negative 2 is the X column. That's there. There's not an X in the second equation. So we have 0 for the X's. So it is A. A, because the X is what's missing. So that's what you have to pay attention to. 3 is the W column. 1. So 3 and 1 should be in the same column. 1 and 2 should be in the same column for the Y's. 5 and negative 4 should be in the same column for the Z's. 10 and 5. So all of those are fine, but the X was missing. So underneath the negative 2 should be 0. Okay. So let's try that. Now, give me the first row. Give me the 4 numbers that go in the first row of this matrix. 4 numbers. All right. Jump in there, Elijah. Let's give this one a try. What are the 4 numbers that go in the top row? Got some folks that have chimed in. We're writing this systems of equation as a matrix. What's our first row? Got a couple of folks have put some numbers out there, and they're different. We have 2 different answers right now. Need a tiebreaker. Okay, Elijah's got us an answer. Jonathan's changing his answer. So let's see. A, B, C, and this. So A, what's the coefficient for the A? -1. It's because it's -8. What's the coefficient for B? Just a 1. What's the coefficient for C? Because that's where I'm seeing people are missing it. -2. Jonathan had -2. -2. That's a -C. -2C. And then 12. All right. Don't forget those negatives. I miss the negatives a lot. When I miss one, it's usually I forgot the negatives. Like, dang it. All right, what's the second row? Second row. What is the second row? This is where it gets tricky because the second row is missing. It doesn't have all the numbers. So the important part is making sure the columns are lined up correctly. This is the A column on the first one. -1A, and there's a 3A. So that goes in the A column. The B column, B was a 1. This B is a 1. So that it was in the B column. The C column, we have -2C. This does not have a C, so the C column has to be 0. And then 12 and -8. All right, check. All right. Yeah, -2. All right. Oh, a challenge problem. I like the challenge problems. Okay, again, they just gave us 2 choices. Which system is represented by this augmented matrix? We're doing the other direction now, giving you the matrix. Love it, Jonathan. Giving you the matrix. Which one of those systems of equation is that representing? B seems to be the consensus so far. Anyone disagree with that? If we look at it, the third row is the same, 5x plus 2y minus z. The second row is the same. The only difference is the first row. So is it -3x minus 5y, or is it -3y minus 5z? X and y, or y and z? And they both equal 8. But if we look at here, 0, 4, 5. 4, 5 is the x column. And we have 0 in the first row. So there's not an X on the first row. So it has to be B. Great job. Wasn't going to fool you guys. Check it. Correct. All right, here's another challenge problem. Ooh, we got 4 of them now. Which matrix represents this system right here? A, B, C, or D? So look at that carefully. Oh, I may have to get some paper on this, because this is going to get somebody. Somebody's going to be messing this up. I'm just betting that we're going to fool you. This is really, truly a challenge problem. This is a good challenge problem. I'm going to turn on my camera because I'm going to walk through this, because even if you guys get it right, somebody's going to mess it up that's not participating. And I want to make sure they understand how to do it. But I'm just thinking somebody's going to be fooled on this. Everyone's saying B. Everyone's saying B so far. All right, I'm going to put this up here. Turn on my light there, get a little more light. All right. Bring this down a little closer. That's a 2. Okay, so we know this is going to be a matrix. That's a 2 by 3, and it's going to have an X column, a Y column, and a constant column, right? We know that. So we should have 2 rows with 3 items each. The question is, what numbers go where? Well, if we look at this first one, 3x plus 2 equals 12y. This is not standard form. We need to move the 2 over and move the 12y over, minus 12y. So this is actually 3x minus 12y equals negative 2. We got to put it in standard form. So this first one is a 3, a negative 12, and a negative 2. Focus. Because these are out of order. This one, negative 8y equals 2x plus 15. We just need to move the x to the right side, the correct side, not the right side. So this is negative 2x minus 8y equals 15. So the x column is negative 2, negative 8, and 15. We're looking for this matrix because we got to put them in standard form. xy equals, xy equals. And this started out with the 2 on the wrong side. It's a negative 2 when it's over here in the constants column. Looks like it's C. So what we got? Because this one has the 2 in the wrong place. They moved the 2 to the other side on B, but they left it positive. Oh, wait, 3. Negative. This one, they've got the negative 8 and negative 2 switched places. Because the X column is first. I thought we might get somebody on that one. Let's see if we're right, though. Okay, that's right. Yeah, you have to make it X, Y constant. So you have to rearrange that one because it was in the wrong place. All right. Thought I might get somebody on that. Okay, that was the lesson. All that's left for this week. The only thing left is this one thing, one assignment, 4 problems. You guys are going to have plenty of time to get caught up. If you got any late work, Matrices is the time to get caught up because this is quick and easy. You can probably have all 3 of these assignments done in about 5 minutes today, unless you have to redo some of them. All right, close the little tab on the side, ready to practice representing linear systems with matrices. Again, make sure you're logged in. It'll keep track of it for you. Write this as an augmented matrix. We got 8x minus 5y equals 19 and 6x plus 11y equals 29. So the top row is the top equation. And I have an 8x. I have negative 5. See, don't forget that negative. And I have a 19. So under the x, I have to have the other x. This is an 8. This is a 6. The y column, negative 5, positive 11. The constants are 19 and 29. So as long as everything's lined up in the correct columns, and I have the correct coefficients, including negatives, should be good to go. All right, let's look at the next one. Which one of this is it? All right, here's another one for the chat. A, B, C, or D. Which one of these matrices represents this systems of equation? So they've got 3x plus 2y plus z equals, no, not equals, minus 7t equals 1. And they have 9x minus 15z minus 8t equals 13. So the thing I noticed right off is this has 4 variables. This only has 3 variables. Somewhere we've got a 0. Which one is it going to be? And what's the answer going to be? Because we've got a 2x4 and a 2x5 as our choices. X, Y, Z, T, 1. It's got to be a 2x5. So C is a fully answer. I just threw that one out there. And the only one, neither one of these even have a 0. It's got a number for every coefficient. I don't know where they got it, but yeah, it's got to be D. Jonathan's on top of that. Because there's missing a Y. There's no Y. 3 and 9 are the X column, but 2 and 0 is the Y column. So it's got to be D. Good work. And again, if you wasn't sure how they did that and you missed it, you can click that and it'll go through the answer. So here was the question. It talks about how you represent matrices. Then it talks about this given matrix. They rewrite it with that 0y, so they both will have all of the variables. Then they rewrite it with the 0 in there. So you know that's the correct matrix. So you can always see how they did it if you were confused. If you just guessed and got it right, you might want to see how they did it anyway, because we're going to have a quiz coming up next week or the week after. I don't remember which week. We got several quizzes. All right, now we have to write another one. This one's not bad. They gave them in the same order, right? X, Y constant, X, Y constant. Just don't forget the negative. This is a -3 and a 5 and 11. Oh, almost missed it. You see that? It's a -11. Got to pay attention. Not 11, it's a -11. Check. Great work. I was about to have to redo it again. Oh, another A, B, C, D. They're all 2x5s, so they didn't throw one of those in to fool us. We've got 5 things in the first, 4 variables and a constant. This one only has 3. So what's missing? 4x. There's no x in the second row. And that's the very first one. So it's got to be A, 4 and 0. Jonathan Shay's on it. You guys are going to blow this. Check. Wonderful. Show summary. Take a screenshot. Boom. Okay, got my screenshot. I go back to Buzz. I scroll down. Paste my screenshot in there. Submit. I'm now done with that. If I go back to the grade screen to see if there's anything else I need to do, I can see that I have submitted all 3 assignments that are due this week. I've submitted all 3. I'm done. If I want to work ahead, if you guys want to work ahead, it's open. Look at this. I've got it open for weeks if you want to work ahead. You don't have to, because we're going to go over them every week in class, just like we did today, but it's open for you. So, like I said, if you're behind on anything, this is a great time to catch up, because these assignments this week are not going to take you very long at all. Some of you may have them done. I'm not surprised when I get done with class and I look and say, oh, some of these people have already turned them in this week. It won't take you long if you haven't done it. I drug out class as long as I can, and we still haven't been here an hour, because these are quick. It'll get a little more complicated the further we get, because we're going to start using matrices to actually do some solving of linear systems and stuff like that later. So it'll get more complicated, but not for a few weeks. It'll be as simple as this. Got you. Okay, thanks, Shay. That'll help. Because yeah, if it doesn't show up in Buzz, I forget to go back and look at Google Classroom, because all the grades in there. So thank you for doing that. But yeah, if you have any questions on any of this, I'm happy to take them. We've got plenty of time. Otherwise, I'll give you this time, the rest of the class, to have this done, and it won't take you the rest of this class, I don't believe. It is an A-day Friday, so I'm here Wednesday and Friday if anyone needs me. I don't know that anyone's grade is below 70%, but if it is, let me look real quick, see if anyone needs to be here. Oh, we do have some grades that have slipped into the 60s and stuff. So I'm guessing some of you didn't get the test turned in last week. That's usually what causes. When we have a test, boom, grades drop for the people that don't turn it in on time, and suddenly those grades are 0 for the test, and that drags your grade down. Some of you have it turned in, and I just haven't graded it yet. So if you turn in the grade, I'll get those graded quick as I can here. I'll try to get them done this morning, so you'll know before grade checks tomorrow. So I'll get them done. If you go to do your grade checks and you look in Hack and you're like, oh, I think I turned it in, you can use the grade in Buzz in your grade check. I'm fine with that, because that's your most accurate grade. I have to type your grade into Hack for it to know what your grade is. So I'm happy with you using Buzz if you want to do that for your grade check. Take the higher of the two. I don't care about that either. So if you want to take the higher of the two. but Buzz is your most accurate grade. So if you haven't got the test turned in, this is a great week to do it. Like I said, matrices are quick and easy. But I will give you the rest of the time, guys. If I don't see you again, have a super spring break. And then I'll see you after spring break when I'm living in my house again. No, I'm not excited about that at all. Anyway, hang around if you got questions, but have a great week, guys.